All right, this is a mistaken page, so just go ahead and skip it. We're going to look at this page, Target 5B, normal distributions. So our maximum objective is I can identify the standard deviation cutoffs of a discrete normal distribution. So there's some words we have to define. First is what is like a discrete probability distribution. So discrete means finite possibilities. And this word finite, it is like infinite, but the original word of infinite. So finite is just the opposite of infinite. It means you can count the number of possibilities. It doesn't go on forever. Really when we're saying like finite, when we talk about like how old someone is, right? You're 1, you're 2, you're 3, you're 4. We don't really ever talk about someone being 1.12357 years old, right? We don't go into those decimals. So that's mostly what we're talking about with like finite possibilities. I guess a better example would be like, how many siblings do you have? I have 2, 3, 4, right? We don't have 2.87 siblings. So people can fit nicely into these boxes, okay? And then the probability distribution, so there's finite possibilities, and the probability distribution is a way to show the probabilities of those finite possibilities. Then a continuous probability distribution is just infinite possibilities. So you usually, sometimes when they're talking about like weights of things, they'll get into more and more. You get into smaller and smaller and smaller decimals. And so the more exact you are, the more it's going to look like this continuous probability distribution. We're not going to do too much with that. We're mostly going to stick with discrete. And the big thing we want to know about is what we call a normal distribution. So this is a probability distribution that varies normally. And again, what we mean by that is a lot of things that we measure in nature vary normally. They have a middle, which we call the mean, which we'll talk about in our next one. But you've probably heard of it, right? The average height of women, right? Most people fall in the middle. And as you go out near the ends, you have less people that are 6'5" and less people that are like 4'11", right? Then you have a lot of women that are like 5'5". So this is your normally distributed, most people in the middle, or most people near the mean, right? And then it tapers off. If it skews, right, that means that's not normal, like most people are clumps near the beginning or near the end. Again, we're not going to look too much at skewing in this class, but if you take AP Stats, you'll look more at that. Okay, for the mean, like I said, you probably heard of mean before, you might have found it. It's just the average. Right, if you find the average of 2 numbers, you add them up, you divide by 2. You have to find the average of 5 numbers, you add them up, you divide by 5. That's finding your mean. Okay, so you already really know how to do that. And the average is a measure of what we call center. There's other measures of center. There's the median and the mode. Again, we're not going to talk about those. We're not going to use those too much this year. But those are also measures of center. And then we have what we call the standard deviation, and this is a measure of how spread out. example, I draw two normal distributions. I can draw one that looks like this, and I can draw one that looks like this. They're both normal distributions. They both vary randomly. This one is more spread out. So higher standard deviation. Okay, so that's all your standard deviation tells you, is how actually spread out your numbers are. Okay, example 1. The heights of men in a survey are normally distributed, as shown in the graph to the right. The mean of the set of data is 70, so that's important. Right, we want to know about our mean. And the standard deviation is 2 inches. What is the what is the height of the shortest man within 1 standard deviation? So I want to go to the shortest. So I'm going to take my mean minus 1 standard deviation. We will often abbreviate it as just SD. So my mean is 70 minus 1 times 2, which is 70 minus 2, which equals 68 inches. What is the height of the tallest man within 2 standard deviations of the mean? Okay, so now we're doing tallest. So I'm going to take my mean and I'm going to add 2 standard deviations, right? Because it's within 2 standard deviations. So that's 70 plus 2 times your 2 inches, right? Which is 70 plus 4. Which is 74 inches. Okay, C and D get a little more complicated. Estimate the percentage of men that are more than 1 standard deviation below the mean. Okay, so I want to know people that are more than 1 standard deviation below. So we already know 1 standard deviation below is 70 minus 2. So we want percentage that is less than 68 inches. That's what we're looking for. Okay. So I'm going to count up how many people I have. So I have 1 person in this box. It looks to be about 3 here. This is maybe 5, 6, say 11, 13, let's say 16. This will say estimate, so we can be, right, this doesn't have nice lines, so I'm kind of generalizing, and that's fine. 14, we'll say 11 again, 8. This also looks like 6, 3, and 1. Alright, so basically underneath I just wrote how many, putting commas between them. I just wrote how many people were in each box. So I'm going to look at my total. 1 plus 3 plus 5 plus 6 plus 11 plus 13 plus 16 plus 14 plus 11. Okay. And I'm just going to add all those up. 4, 9, 15, 26, 39, 49, 55, 69, 80, 88, that's 10, I believe it's 98 total. So I want to find the men that are more than 1 standard deviation below the mean. So they have to be more than 68. So here's my cutoff. Since it's more than 1 standard deviation, I'm not going to include 68. So I'm going to include everything that's below that. So 1 plus. Right, so I'm just adding all of these up out of my total. So this is very similar to what we did in our probability unit. 4, 9, oh, can't count, 15, 26. It does want it as a percentage, so I'm going to get that as a decimal. So that's 26.5%. All right, D, estimate the percentage of men that are within 2 standard deviations of the mean. So I want to do 70 minus 2. Sorry, 70 minus 2 times 2, because 2 standard deviations, my standard deviation is 2, which is 70 minus 4, which is 66. And then I want to do 70 plus 2 times 2. All right. So those are my cutoff points. So 66 and 74. Here they're within, right? So I want 66, our percentage, right? Between those, and here it's within, and so those do count as part of it, right? Here this one didn't because it was strictly left that are more than. Here within 2 standard deviations, those are going to count with it. So I have 5 plus 6 plus 11 plus 13 plus 16 plus 14, 11, 8 plus 6. All over 90. 58. This up a little bit. The other thing you can do is count just like the outsides, right? But if you add all these up, you get 92 out of 98, which is 93.9%. And that's very common to have that many of much of your data within 2 standard deviations. Getting more than 2 standard deviations is getting well out of the realm of your probability. Okay. All right, let's look at one more example like this. Okay, the actual weight of bags of pet food are normally distributed, as shown in the graph. The mean of this set of data is 50 pounds, and the standard deviation is about 0.1 pounds. What is the weight of the lightest bag within 3 standard deviations of the mean? So, again, it's lightest. So 50 minus 3 standard deviations, which is 0.1. Which equals 49.7 pounds. What is the weight of the heaviest bag within 1 standard deviation? So heaviest, so I'm going to add the standard deviation. 50 plus 1 standard deviation is 0.1. Estimate the percentage of bags that are more than 2 standard deviations above the mean. So now again, I have to count up all my totals. 1, 3, 6, 13, 17, 20, 18, 12, 5, 3, 2, right? So again, I'm just putting what number this is. So 1 plus 3 plus 6. Four, 10, 23, 40, 60, 78, 90, 100. Good. Nice number. So the percentage of bags that are more than 2 standard deviations above the mean. So I want 50 plus, right, because it's more than 2 standard deviations above. 2 standard deviations. Which is 50.2. So there's my cutoff. Right, and that one's not part of it, so just 5, 3, and 2. Right, and since this is out of 100, it's very easy to say what the percent is. Right, 10%. Estimate the percentage of bags that are within 1 standard deviation. So within, again, we need to go 1 below and 1 above. Which is 50 minus 0.1, which is 49.9. And then I do 1 above plus 1 times 50 plus 0.1, which is 50.1. Okay, so that's why I want to be between 49.9 and 50.1. And with the within, those are included. So I have 17 plus 20 plus 18. All over 100. Sorry, this is an 18. Which is 20, 30, 40, 55. I'll move it up so I can write. So that equals 55%. Okay. All right, and that is it. I'll see you guys after Thanksgiving. Have a wonderful Thanksgiving break.